So this chapter is about the blood. This is slide number 18. It's about the blood. And the blood, we will be talking about uh, two different main things. Number one, the purpose of the blood, and then the composition. For the composition, we have three types of cells located in a fluid called plasma. So there is fluid part called plasma, in which there are three different types of cells that we are going to talk about. Besides, we will be talking about hematopoiesis, which is making the blood cells, manufacturing the blood cells. Also the blood types, and if somebody's having injury or bleeding or something, how is it going to stop? And we call that hemostasis. Hemo means blood or bleeding. Stasis means to slow or to stop. So again, blood is one of the connective tissue, and it is two components, fluid part called plasma, and three different types of cells that we will talk about their functions. But generally speaking, if we put blood in general, including everything, what will be the hormone, the functions? Most importantly, transport. Transport. We talked about this when we did the circulatory system because the blood moves within the circulatory system. So this is something in common, which is transport. What are you transporting? Anything that need to be transported. You're transporting oxygen, nutrients, hormones to the cells. And then you're also transporting carbon dioxide and waste products away from the cells. We talked about this in the cardiovascular system. This is generally speaking as blood as a carrier from the heart to the cells and from the cells to the heart. Carrier, transport. This is one. Number two will be specific functions. So we have white blood cells. Yes, white blood cells for immune system. It's part of the immune system to fight infection. To fight infection. Hemostasis. Yes, hemostasis is regulated if you have bleeding or something, if somebody's having bleeding, and other things also are regulated. Hemostasis is the function of the platelets, plus the blood itself regulate different things, including blood pressure. What does that mean? Means if you have more blood inside your circulatory system, let's say the average is about 5 liters for adults. If you have 6 liters, your blood pressure goes up. If you have 4 liters, your blood pressure goes down. So it's regulating the blood pressure. That's one. Number two, regulation of the body temperature. And we talked about that before. Again, if it's getting hot, your blood vessels are going to dilate. Blood that we're talking about right now will shift or go from the core of the body where it is hot or higher temperature out to the skin because of that dilation, losing some of the heat. So this is regulating the body temperature if the temperature is going up. If it starts to go down a little bit, you're doing the opposite, which is constriction to keep your blood in and you don't lose part of your temperature. The other thing is controlling pH. pH is the measurement of acidity versus alkalinity. We talked about that before. And yes, the blood is helping that. If it's getting acidic, it will help return it back to normal. And if it's getting alkaline, it will help returning it back to normal. And this is general idea about the blood. And the blood, again, is composed of formed elements formed, and these are the three types of cells. Red blood cells, white blood cells, and platelets. And then the plasma. What's a plasma? The fluid component of the blood. For the formed elements, which are the different cells, the vast majority are red blood cells, 95% red blood cells, followed by platelets, followed by very small number of white blood cells. It's not really small. It is sufficient to do the work. And again, platelets. Why do we have platelets? We will talk about it again, but these are the basics. We have to know it. To stop bleeding. Hemostasis. Stop bleeding. It make blood clot to stop bleeding. Red blood cells. Yes, red blood cells are mainly carrier of oxygen and also carbon dioxide, but oxygen is number one. White blood cells, generally speaking, fighting infection, fighting pathogens, same thing. So it is part of the immune system, but we need to remember the three words: infection, pathogens, part of the immune system. Being part of the immune system, it fight pathogens, it fight infection. There are different types of white blood cells. These types are neutrophils, eosinophils, basophils, monocytes, and lymphocytes. So these are the 5 different types, and each one of those has its own specific function, but for now, we need to know the names. What are the different types of white blood cells? Neutrophils, eosinophils, basophils, monocytes, lymphocytes. How about the plasma? The plasma is basically the fluid component. The most of it, the vast majority, the major part, 92% is water. Water. What else do you have in the water? I have good amount of proteins like fibrinogen, globulin, and albumin. Each one of those is a protein dissolved in in the water component of the plasma, and each one of those is having a function. What else do we have in the plasma? Besides water and proteins, we have some electrolytes, sodium, potassium, calcium, and so on. Since you're carrying waste products and gases, this is part of the plasma. Gases are like carbon dioxide, oxygen, and nitrogen, but the most important oxygen is carbon dioxide. You also carry nutrients. Nutrients. What do you mean nutrients? Like what you absorb: glucose, fructose, proteins, fat, whatever it is. Plus, you're carrying vitamins and hormones. You carry also waste products like carbon dioxide and other things like urea and so on. So plasma is, which is a fluid component, is more than half. This is like 55%. And what I want you to know is right here. We already mentioned it. What are the components? Water is 92%, followed by proteins, and then electrolytes, waste products, gases, nutrients, including vitamins and hormones. You said proteins, we have albumin, globulin, and fibrinogen. What's the uses of for albumin? Both albumin and globulins are carriers, transport. Plus, albumin is responsible for the viscosity of the blood. We call it the osmotic pressure. Like, is it thick? Is it thin? Globulin, beside being a carrier, it's part of antibodies. Fibrinogen, it helps blood clots. I'm saying that in simple words. So this is just repeating it. And here are the plasma proteins. I told you what I want you to know already. Anything else is, you can read it if you want to, but I already told you what you have to know in this slide right here. And it is kind of repeated, but this is what it is. So let's talk a little bit about the cells. Red blood cells have another name, erythrocytes. What does it mean? How to translate? Erythro is part and cyte is part. Erythro means red. It's Greek for red. Cyte is Greek or Latin for cells. Cyte is cells. Cytes, cells. So erythrocytes, red cells. It is basically transport of oxygen and carbon dioxide. You have to know this. These are the basics. And I mentioned it before, repeating. How about the white blood cells? Yes, translation. Leuco means white. Cytes mean cells. So leukocytes is the other name for white cells. And this is body defense, meaning body defense. Defense against what? Pathogens, infection, because it's the immune system, part of the immune system. Thrombocytes. What are thrombo? Thrombo means clot. Cytes mean cells, the cells that make the blood clot. Why do we need blood clot? If you are injured and you're bleeding, you know that it's going to stop after a few seconds, right? It bleed a little bit and then stop. And if you look at it a little bit later, you will see it, something closing it. This is the blood clot. Red blood cells or erythrocytes, it looks like this. Look at this shape. It's biconcave shape, and these are the smallest cells. Biconcave, the smallest in size, but the highest percentage, the largest amount. Of course, amount and size are two different things. Smallest in size, but largest amount. And it looks like this. Okay, you told us that it carry oxygen and carbon dioxide. Where? Yes, in the hemoglobin part of it. Inside of it, there is hemoglobin. This is what carry the oxygen. And when it carry oxygen and carbon dioxide, but when it carry oxygen, it will look red. Do you guys remember in the cardiovascular system that we finished? I told you that when the blood is oxygenated, it looks red. Remember the red part after the lung, pulmonary veins, left atrium, left ventricle, aorta, and arteries, and so on. It's red. And we see the color red. Why? This is hemoglobin. When it contains oxygen, it looks red. Where do we make all the blood? Bone marrow, from the stem cells of the bone marrow. Okay, there are stem cells, the mother's or grandmother cell. We call that grandmother cell, from which all the cells come. All of them come from the same grandmother cell. And these grandmother cells are called stem cells. We need to remember this. Where is this stem? Where are these stem cells? In the bone marrow. Which bone marrow? Red bone marrow. Where is that red bone marrow? Which part of the bone? Spongy bone. We talked about that in the bone. I'm reminding you. It is in a spongy bone, not in the compact bone. Spongy bone. Here it is, stem cells. Stem cells are going to divide and divide and divide until it gives you the different types of cells, including red blood cells, white blood cells, and platelets. I'm not going to go through the details. Just look at this picture. Look at the inside. This is the spongy bone. This is the location of the red bone marrow, which contain the stem cells, from which it will go in different directions, cell after cell, until it end up giving you the different types of cells. What are the different types of cells? Red blood cells, white blood cells, and platelets. So white blood cells, I talked about it already. And the white blood cells, again, housekeeping, meaning cleaning and defending. Clean, defense. Clean and defense. Defense against what? Infection and pathogens. It's part of the immune system. I'm helping you memorize. Remember this. Normally, the white blood cells are between 5 and 11 thousandths per microliter, and this is normal. And obviously, because they are responsible for fighting infection and pathogens. If you are infected actually, and if we count your white blood cells, we will see them going up. If we wanted to know if you're having an issue or not, we can do blood count. Blood count can tell you, like, you have 11,000 white blood cells. You have 5 million red blood cells. You have 100,000 platelets. This is just big numbers. But there is something called differential count. I don't want you to know the details, but just know that differential count mean you don't give me a bulk number. Like if I say the school have 900 people. Yes, 900 what? Like 800 students and 20 teacher and 2 workers and or 10 workers or whatever. So these are the details. So you can give me a bulk number. How many white cells do you have? 11,000. And you can do it differential. You be more specific. And again, white blood cells go up if you have infection. But it goes extremely high if somebody's having leukemia, which is cancer, versus leukocytosis. One more time. You should have normal count of the white blood cells. Okay, 4 to 11,000. What if it's more than that? That's high. What if it is less than that? That's low. You're supposed to be in the range. Not only this, everything in our body should be within the normal range. What if it's not in the normal range? This is not normal. So what if it goes up? It's called leukocytosis. And it means most likely you have infection. And it goes up like instead of 11, 15,000, 20,000, something like this. But if it goes like 200,000, that's not high. That's extremely high. And this might be cancer called leukemia. And it can also go down. If it goes up, we call it leukocytosis. And if it goes down, we call it leukopenia. Leuko means white. Cytosis means high number of cells. Here, the white blood cells, they move in the blood, leukocytes, which is the white blood cells. And if they find something, they can move, squeeze themselves out of the blood vessels and go to the different parts in order to fight. Platelets, the other name is thrombocytes. We have millions of those. And what's the function? Blood clot. Hemostasis, blood clot. Stop bleeding. This is what's doing. So what's is blood, fluid part, which is plasma, and 3 types of cells, red, white, and platelets. Plasma is the liquid or fluid part. Contain many things. It was in the slide. Red, hemoglobin, which contain iron, and this is carrying oxygen and carbon dioxide. White blood cells, housekeeping and defense. Housekeeping and defense. Defense against what? Pathogens, infection. It's part of the immune system. How about the platelets? Blood clot to stop bleeding. When the oxygen is carried on the red blood cells, it attached to hemoglobin, and we call that oxyhemoglobin. Oxyhemoglobin. Oxy, oxygen, hemoglobin, hemoglobin. Very simple. Oxyhemoglobin. Hemoglobin carrying oxygen. And if the hemoglobin is carrying carbon dioxide, we call it carbamino hemoglobin. Carbamino carbon dioxide attached to the protein of the hemoglobin. So carbamino versus oxy. Hemoglobin itself is two parts. Hemo, that's the part that contains iron, and globin is a protein. And here it is. This is oxygen being carried on the iron part of the hemoglobin within the red blood cells. So I talked about oxygen and carbon dioxide. Okay, you carry oxygen to the cells and you carry carbon dioxide away from the cells. How about the carbon monoxide? Yeah, carbon monoxide is something that's not supposed to be like like carbon dioxide. We always have it in the atmospheric air. Carbon monoxide, it should not be there. And if it is there, it should be very, very small amounts. The thing about carbon monoxide, carbon dioxide, it's carbon and two oxygen. Carbon monoxide contain one oxygen only. Carbon monoxide is a lot worse than carbon dioxide. It's colorless, you can't see it, you can't smell it, and that's why they always tell you in your house you have to have carbon monoxide detector. Why do I have to? Because you don't know. You have no idea. People can just die, and they realize later that they died from carbon monoxide. How come? Like why I didn't smell it? Because it doesn't smell and it doesn't have a color. There is nothing. You don't have an idea. No idea what's happening. But it was carbon monoxide. And that's why we tend to have these carbon monoxide detectors. You should have it in your house just in case, you never know. And this comes from the car exhaust and other things. I don't know if you guys heard of that or not, but just to help you remember the information, it happened before that, like last year or something, that somebody puts another person in his garage and close the door and put a pipe with the exhaust of his car into that garage, and the person inside died from carbon monoxide. It's extremely dangerous. So hemoglobin again is the part of the red blood cells that carry oxygen. So if I ask you, what's the function of the red blood cells? Carry oxygen and carbon dioxide. Which part specifically carry oxygen? Hemoglobin. Which part in the hemoglobin? Iron. Iron of the heme of the hemoglobin. If that's the case, we call it oxyhemoglobin. If oxygen is attached to hemoglobin, specifically to the iron of the heme of the hemoglobin, we call it oxyhemoglobin. Otherwise, if it is carbon dioxide, we call it carbaminohemoglobin. Red blood cells stay for about 4 months and they do not divide. This is something important to remember. So this slide is important. How long does the red blood cells, what's a lifespan? How long do they stay? 120 days. Does these cells divide like before they die, like one make, two make? No, no. You are going to make brand new cells. You're going to break it down, recycle the components, send the recycled component to the red bone marrow to remake ones from scratch. So no, it does not divide. Why it does not divide? Because it does not have even a nucleus or organelles. No nucleus, no organelles. How can it divide? It does not. It does not divide. We actually make it from the stem cells in the red bone marrow. And when you make it in the stem cells, you make it from part of it. It's from the recycled components of the ones that died. It's not really died, it's broken down, recycled. So remember, the red blood cells does not divide. We make it from the stem cells in the bone marrow. Why does not divide? Does not divide because it does not have nucleus. Never. No, when it was young, still developing, it had a nucleus. But I'm talking about the mature red blood cells. This, in order to make it, there is a hormone that I want you to remember its name that come from the kidney. And this one is the one that stimulate the bone marrow to make red blood cells. And this hormone come from the kidney is a very important one that's called erythropoietin. For short, they say EPO, like this, like E for erythro, PO for poietin. Erythropoietin come from the kidney, go to the red bone marrow to make more red blood cells. Why the kidney secreted? To make more red blood cells. Yes, but why? How the kidney know that we need it? Because the kidney itself, it receives blood. If it receives less blood, it means we need more blood. It make erythropoietin, go to the red bone marrow, stimulate the stem cells to make more red blood cells. And by the way, when we're done with the red blood cells, we send it to the spleen and the liver to be broken down and recycled. For your information, the remnants of that is bilirubin. If you ever heard about jaundice, it shouldn't happen. We should recycle it. But if it is too much remnants, it goes up, making yellow discoloration. This is just for your information. Can the red blood cells number, which is about 5 million, can it go up? Can it go down? Yes, it can. If it goes up, we call it polycythemia. If it goes down, we call it erythropenia. So it can go up and go down, can go down. If you go to the lab, what they do is they get the blood sample from you, they put it in a test tube like this, and they have a machine called centrifuge. It rotates fast in order to separate the blood into formed elements right here, the cells, and the fluid part will be up here. And this is basically because of uh, the gravity and so on. So the plasma will be on top and the cells will be at the bottom, and in between, the cells, red blood cells specifically, will be at the bottom, and in between the other two cells. And again, just remember that the average is 5 million. Good enough to remember. 5 millions. Mature red blood cells, do they have nucleus? No, they lose it. What's the lifespan? About 4 months. What's the hormone from the kidney? Erythropoietin. Very important. And that's why they put it in this slide right here. Now, there is a word which is agglutination. Agglutination is clumping. The red blood cells, each one should be separate. It can happen that they come together, clump together, and we call that agglutination. And that only happen if somebody receive incompatible red blood cells. Example, your blood is type A, and they give you wrong type of blood. They should give you A or O. I think we all hear about universal donor and universal recipient. Universal donor is O. Universal recipient is AB, if you heard about this. So if you're type O, you can donate to every person, every other type, but you take only from your own type. If you're AB, you can take from anyone. You can take from anyone, but you give only your type. Universal donor, universal recipient. So let's say, example, I am type B. What kind of blood can I take? You can take type B, your type, plus the universal donor. What if I give you type A? Is that okay? No, it's not okay. Because in your blood, in the plasma, you have antibodies against anything that's foreign. And this is foreign. because it's not your type. So these antibodies are going to attack the red blood cells, clumping them together, and we call that agglutination, like this, like the arrows. Look at these individual red blood cells. It should be individual like this, like each one is all by itself. But when they clump together like this, they aggregate together like this, we call it agglutination. And this only happened if somebody received incompatible red blood cells. Agglutination occurred. So the red blood cells will have different types. I think we all heard about the ABO system, which is you either type A, your type B, AB, or O. This is one differentiation. The other type is easy one. These are different types, but some people have another marker, another antigen on their cells that's called RH. You have it, you're positive. You don't have it, you're negative, and that's it. There are no types. So if I ask you, what's your blood type? You don't say B. No, you have to say B positive, two parts. The blood group is something which is A or B or AB or O. Plus, do you have RH or not? It has to be compatible as well. So always, like if you ask me what's your blood type, I will tell you I'm AB positive. I will not say AB. I will say AB positive. I'm giving you two pieces of information. My blood cell type is AB. An RH, yes, I have the RH. So I'm positive. You don't have it, you're negative. So why is it type A, type B? Because you have a marker that's called A, or you have a marker that's called B, or you have two markers or antigens. If you have both of them, A and B, you call it AB. What if you don't have any markers, which is the antigen? We call it zero. And zero, we refer to it by O, zero. Understand this. Where does the name come from? A or B or AB or O? A, you have marker A, which is antigen A. B, you have marker B or antigen B. AB, you have both markers, both A and B, both antigens. How about O? O refer to zero, nothing. You don't have any antigen or marker. And that's why if you are type A, you have marker A or antigen A. And you have antibody against the foreign one. That's not yours. You're type A. What's the foreign one? B. If you're type B, what type B means? My antigen is B on the red blood cells. And because of that, you have antibody against the foreign one, which is A in this case. If you're type AB, you have both of them, both antigens or both markers. So what kind of antibody do I have? You don't have any antibodies because there is nothing foreign to you. I have both of them. Why should I have against A if I have it? Why I have against B if I have it? So no, you don't have any antibodies. For O, O means zero. What do you mean by zero? I mean there are no antigens. Since you don't have antigens, so any will be foreign to you. So you will have anti-A and anti-B. You can give these, look at this nice red blood cells that does not have any antigens. You can give it to anybody. It doesn't have antigens. So any blood will not attack it because it doesn't have antigen. So here it is. The name come from this, from the blood. The name come from the antigen. Type A, what does it mean? You have antigen A. Type B, you have antigen B. AB, you have both. O, zero, you don't have any. And if you have type A antigen, you have antibody against the foreign one, which is B. If you have antigen B, you have against the foreign, which is A. If you have both, you have against the foreign, there is no foreign. You have both of them, so you don't have any. If you don't have any antigen, you will have against both of them because both are foreign to you. So if you give wrong blood type, let's say uh, those two types. Let's say you are type A, so your antibody is B. What if I give you type B? Type B will have anti-A and they will clump together. They are going to react together, making agglutination. It should look like this. Look at this. Scattered cells, individual cells. But look at this. They clump together. This is how it actually looks like. If you go to the lab, it looks like this. RH again, yes or no. That's it. You have it, you don't have it. If you have it, you're positive. If you don't have it, you're negative. The importance of that is in one thing, basically. Pregnant ladies. It's more people have RH than people who don't have it. If you have it, you're RH positive. If you don't have it, it's negative. So let's say if a dad is RH positive and a mom is RH negative, the baby will be RH positive because RH is strong, it's dominant. So it will be inherited. So what is this fetus inside the mom, the baby? It's positive, and the mom is negative. If that's the case, this is an issue because during delivery, will be some mixing of the blood, and the mom will make antibodies against that, but it will the first baby will not be catched because it's delivered already. But when it's delivered, some blood will mix, and the RH negative mom, she will see a foreign antigen, which is RH. She's not familiar with this, so she will make antibodies against it. So the problem is the second baby. If she's pregnant again, she already have the antibody. So once the blood mix, her antibody will attack the second baby, and the second baby can actually die. Does that actually happen? It used to happen like in ancient time, not anymore. Why? Simply because you need to follow up with your doctor, with your nurse, and it's basics like ABC. Like if you go to anybody, the first thing that they will do is if you go to the doctor, let's say, I'm here to follow up. Okay, number one, before doing anything, what's your blood type? It's type A negative. How about the dad? He's type A positive. I will tell you something here. Your first baby will be okay, but after you deliver the first baby, I want you to come back. I'm going to give you something to wipe off these antibodies. Otherwise, your next pregnancy, your second pregnancy, will be exposed because you will form these antibodies and it will stay in your system. The second time, your antibodies will attack the baby and the baby can die. So to prevent that, there is a treatment, fortunately, and it's automatic. They will tell you, remember, after the delivery of the first baby, you will make antibodies against the RH. So you need to come to me. I'll give you something called ROGAM. You don't have to know that, but I'm just giving you information. It's called ROGAM. I'll give you the ROGAM, which will remove and wipe off your antibodies. So guess what? What's going to happen? The second baby will come when the blood mix, there is no antibodies, but she will make it. So the third baby, we have to do the same thing. So the bottom line is, okay, I want you to know that every single time I want you to come back to give you the ROGAM. I think this is an interesting piece of information. If you know somebody have it or something, it's interesting. So here are the different types, positive or negative. And here is the compatibility that I talked about. And this is the scenario that I was talking about. The dad is positive, the mom is negative, the baby will be positive because positive is dominant. If the mom is positive and the dad is positive, both of them is positive, the baby will be positive. If one of them is positive, the baby will be positive. The only time that the baby is negative is if both parents are negative. But if in this case he's positive and she is negative, what do you think? I don't have to do anything. I will tell you right away. Listen, your baby is positive, just like this. So what does that mean? What do you want me to do? I want you to come after labor, after delivery, and I will give you ROGAM to get rid of the antibodies, these that formed, so that the next baby will be safe. Here is the ROGAM I was talking about, and this will remove the antibodies so that the next baby will not have that issue. So according to the ABO system, the types are A, B, AB, and O, and RH positive or negative. If you receive blood, it should be compatible. If it is incompatible, what's going to happen? Agglutination, clumping, aggregation. The cells come together. And when the cells come together clumping like this, they are going to be destroyed. For RH, I talked about it. And next is platelets. Platelets are responsible for what again? Stop bleeding. What do you call it? Blood clot. You make blood clot to stop bleeding. Bottom line. You make blood clot to stop bleeding. We call that hemostasis. The platelets do that for you. How? Steps. Number one, blood vessels constrict. So less blood is lost. And then the platelets close that area that was opened. And then you make the actual clot or thrombus that's going to close it until your blood vessels heal back. This blood clot that form here, that's completely normal. It's made there to close the injured blood vessel so you don't bleed anymore until the blood vessel heal itself. But if you form it for no reason, like you don't have injury, but you make it, this is an issue that can move in your blood. This thrombus can move in the blood. If that's the case, we call it embolus, and it can go block somewhere, causing something like stroke. You don't have to know details. Hemophilia is if your blood cannot clot. It's a genetic disorder in which the blood does not clot properly. That's it. The blood clot that you made at the end is made of platelets that we talked about, plus fibers called fibrin. Okay, so platelets make the plug, fibrin make the clot. That's basically what we need to know here. Okay, so this is the summary going through the blood with the plasma and the different cells. Inside the red blood cells, hemoglobin and oxygen, lifespan, the ABO typing and RH typing, platelets, hemostasis, including vasoconstriction, including platelet clot and or platelet aggregation, and then the actual clot, which is fibrin. And that's it. So let me stop here.